Let's take a look at exercise 1309, number 10. Excuse me. So here we've been asked to solve the equation. We're trying to find the value of x. I've restated the problem here. And we've got, obviously, fractions on both, algebraic fractions on both sides. And a little bit of a nuisance, really. In fact, have I written that incorrectly? I have. So it's just checking it. It's 2x on 3 plus 6. 2x on 3 plus 6. There it is. All right, well, let's go ahead and do that. So my way of doing this really would just be to deal with the little bits on each side and gradually whittle it down till I got nothing left. And to do that, I'm going to, first of all, add the fractions on this side, and I'm going to add the fractions on that side. Now, there's so many different ways of doing this, but this is what I would do. So I would say, well, that implies that. And the first thing I'm going to do is draw a long vinculum and go 4 times 2. So 4 times 2, that's my first step. 4 2s are 8. Then I'm going to go 2 lots of this lot, 2 lots of x plus 5, plus 4 lots of 3x minus 1. And that all equals, I'm keeping the equals under each other as best I can. Now this one here is really very, very straightforward to do. I've got 2x on 3, but I got plus, and I got a 6. Well, if I want to turn 6 into thirds, I just multiply it by 3. Because to get rid of a denominator, we always multiply it by 3. Or to add a denominator, I'm going to multiply it by 3. So I'm going to multiply that by 3 and put the 3 underneath. Because, of course, 3 divided by 3, this leaves me with 6. But 3 6s are 18 on 3. So that I've turned a 6 into 18 on 3. All right, so let's go ahead now. I'm going to, what am I going to do here? Oh, I like this one. In fact, the first thing I'm going to do is divide everything by 2. Divide this by 2, divide this by 2, divide this by 2. So that divided by 2 is 1. This divided by 2 is 4. This divided by 2 is 2. So I end up here now with x plus 5 plus 2 times 3x minus 1 all on 4 is equal to, now these are all thirds, so I've got 2x plus 18 on 3. Nice and simple. I'm going to expand the bracket out here, and then I'm going to collect like terms. So let's see, this implies that I've got x plus 5 plus, this is 2 lots of 3x is 6x, minus 2, and all of that, of course, is on 4. So I keep this the same on the other side. Now I'm going to collect like terms. I've got an x and I've got a 6x, so I'm going to have 7x, and a 5 minus 2 is going to be plus 3. This is all over 4, and that is equal to 2x plus 18 on 3. Now, simple. I've got 2 fractions either side of equals. I'm going to cross multiply. So I'm going to do this first. I'm going to go, well, 3 lots of this. So we're going to have 3 lots of 7x plus 3 is equal to 4 lots of 2x plus 18. Nice and straightforward. I'll put my implies that sign there so I can just see that I'm making a link between each of the steps. Equals, well, 7 3s is 21x. 3 times 3 is plus 9. 4 2s, that's going to be 8x. 4 18s, crikey, what's that? 72. Okay, that makes sense. I think that's right. Minus 4, 6, 4, 8, 32. Yeah, that's right, great. Okay, that was a worry. Okay, let's get rid of the 8x here. I'm going to get all the unknowns on the same side, so subtract 8x from both sides. So 21 minus 8x is going to be 13x plus 9 is equal to 72. So now I'm going to subtract 9 from both sides. So subtract 9 from this side, subtract 9 from this side, and I'm going to have 13x is equal to 72 minus 9 is 63. Divide both sides by 13. Now I'm dividing by a prime number, and 13 actually doesn't go into 63, so I'm left with x, because 13 divided by 13 is 1. 1 times x is x, and x is equal to, and I really can't reduce this any further, so I'm just going to leave it as 63 on 13. If you wanted, you could make this oh, sorry, what have I done? Nah, crazy talk. That's just not good. 63. I think it's 16. I must be thinking 30. Okay, right, okay. So 63 on 30. Now, important, you could make that an improper if you wanted, which would be, I don't know, 4 and something or other. But I really wouldn't bother. It's much better, it's preferable to have improper fractions than to have mixed fractions or mixed numbers. So I would definitely say that would be the answer. And I would leave it at that point.